Hello guys, welcome back. Let's go through another use case of LangChain. I hope you already know what is Auto-GPT. If not, it is an experimental open source attempt to make GPT for fully autonomous, right? Within around 1 month, they have 119,000 stars in GitHub, and there are many applications being created using Auto-GPT. There are many ways how you can run Auto-GPT locally, and I have already created a video, or you can also follow the documentation which is provided in the GitHub. They have explained step by step process how you can get started. But in this video, I will show you how you can create the Auto-GPT using LangChain. Let's get started. The code is in my GitHub repository and the link is in the description box. First thing first, there I have provided the links here. As I said before, it is based on the Auto-GPT GitHub repo, and we are going to implement this with LangChain. Right, here is the link. You can go through this. First thing first, you need to install the packages. Right here, I have just passed the shell where I'm installing the packages. Now let's set up the tools. Right, what we do to set up the tools, as I'm saying here, when I install the packages, I'm going to use the LangChain Google results, because we are going to use Google in order to find the results, and the FICE CPU because we are going to use the vector store as FICE here, and OpenAI, of course, we are using the OpenAI chat models. Setup tools first. You need to go through this link. If you haven't already created the account, you need to create the account for the SERP API as well as OpenAI's platform. After you get the API keys, just replace this in this string. Then you are good to go. What we need to do now, we need to, of course, import the necessary classes from the LangChain. Here I am importing the SERP API wrapper from utilities, and from the agents I am importing the tool, and from the tools.file management write and read I am importing write file tool and read file tool. We need to have the agents read something and write something in the file for us automatically, right? Next, what I am doing here is there is the search API wrapper, and there is the tools variable being created, and I am creating the tool here. The name is search and the function is just the search.run because we need to run the Google search, and the description you can just provide here the description. And after that, we are also passing the write tool and the read file tool. I can just run this shell for now. By the way, if you want to know some documentation about something in notebooks, it's really simple in Google Colab. You can just hover on top of the class you want to have the documentation, and you can see here it says open in tab or view source. If you click the view source, it will just open on the right side of the screen. You can go through here and see what is being implemented in the code itself. You know better what is the code doing behind the scenes. Okay, now we set up the tools. Next, we are going to set up the memory. The memory is used for the agents in the intermediate steps, because we are just letting the agents do the job for us, right? We are going to use the wrapper around the FICE vector database. If you want to know what is FICE, I have provided the link here. You can go and view what it is. Here I've explained for you like what is embeddings, what is index, and what is vector store and all these things, because when we create the memory, you need to have the understanding of this, because machines just understand the numbers. So first, if we pass some string into the model, we need to first convert that into the embeddings, and we need to store that somewhere, right? Then comes the vector. It is the specialized data storage system optimized for storing and retrieving the embeddings. And we need to also have the index. In short, an index is where you load, manage, and query the data. Why we need all these things is because when the language model needs to look up an embeddings for a word or phrase, it uses the index to find the corresponding embeddings in the vector store. That is how it actually works. For that, what we can do is we need to first import the necessary classes again. Here I'm importing the in-memory docstring from the LangChain.docstring. I'm importing the FICE from vector store of a LangChain, and there is the OpenAI embeddings. Let's just run this command. Now we need to define our embedding model. As I said before, we are using the OpenAI embeddings. You can also use Hugging Face and other embeddings. And we need to initialize the vector store as empty before, right? We import the FICE first, and the embedding size is 1536. because OpenAI embeddings has 1536 dimensions. It cannot hold more than that. And here is the index. As I said before, we are using the files dot index flat L2, and then we are passing the embedding size inside this. And after that, we need to create the vector store, and we are passing all the things here. You see the embeddings model dot embed query, we pass that, and we also pass the index, and we also pass the in-memory doc strings. Now we have all the necessary pieces together. We can go and set up the model and AutoGPT. By the way, it's not that difficult, but you need to know what you are doing step by step, right? That is the main thing here. When you implement something or when you create the application, you need to know what comes after each and every step, right? Now we need to set up the model and AutoGPT. As I said before, we are using the chat OpenAI model. From LangChain experimental, we import the AutoGPT class, and from LangChain.chat models, we import the chat OpenAI. There are many models, but we just want to use the chat OpenAI. And now we need to create the agent. This is the main part, right? For the agent, we said that we are using AutoGPT dot from LLM and tools. We are passing the AI name. You can pass anything. AI role, you can also give anything here. And tools, we are just passing the tools that we created up here, right? And then we pass the LLM, meaning that the large language model. In this case, we have chat OpenAI, and the temperature is 0 for now. And the memory, we are going to use the vector store, as it says here, dot as retriever. That's it. And then we just want to have the agent.chain.verbose equals to 2. Why verbose? Because we want to see what the agent or AutoGPT does behind the scene, right? Now let's run this shell. I have already created one example before, but for now, what I will do here is I will run the example for you. Now we need to run the example. That's that simple. We created the agent here, right? And now we have to just run the agent. I'm saying here agent.run, recommend 5 movies to watch, which is similar to Avengers. If I run this, it is going to show all the things for us. It says that, okay, entering a new LLM chain, prompting after formatting and so on. We can actually go through this. Let's go, what is here? System, you are Tom assistant, as we provided the name. So your decision must always be made independently without seeking user assistant. Play to your strength as the LLM. You see that these are the main things that are passing here. And there are the goals, right? Goal is recommend 5 movies to watch, which is similar to Avengers. And the constraints, here is the constraints also. Around 4000 word limit for short-term memory. Your short-term memory is short, so immediately save important information to the files. Because we have the write file and read file, right? What it will do is it will write into the files and it will read into the files. By the way, it already completes, and let's go step by step. I don't even need to go through the first example. What we did here, so let's go step by step. Constraints is here, and there is the command, so you need to search, right? Useful for when you need this, we just passed before. Here is the write file to the disk, read file from the disk, and the finish command is use this to signal that you have finished all the things. These are the constraints, these are the commands, right? And the resources now. Internet access for searches and information gathering, long-term memory management, GPT 3.5 powered agent for delegation of simple tasks, file output. The performance evaluation, it just says all the things here. And now it says you should only respond in JSON format as described below. You can see here, these are the thoughts, like thought, reasoning, plan, criticism, thought summary to say to user and all these things, but we don't have the speak feature now here implemented. You can see how it is being formatted inside. And here is the system, command write file returned, human determine which next command to use and so on, right? It went through some of this, and here it says finished chain. If we scroll down, it says entering new LLM chain, prompt after formatting, system, you are Tom assistant, your decisions must always be this. Okay, all the things. Recommend 5 movie. It's the same thing here. If we scroll little bit down, it says finished chain. Okay, command finish, response, I have completed all my objectives. If we now go to this folder, there should be a file being created. You see here similar movies.txt. This is the weather report that I ran before, but as it went much faster than I anticipated, let's go through the similar movies.txt. Here you can see I just asked 5 movies, and here it gives the Dark Knight, the Matrix, Inception, the Avengers, Age of Ultron, and Captain America, the Winter Soldier. I think it gives quite well, right? Because I said here, what was my question? Let me scroll up here. Okay, I said similar to Avengers. Yeah, it is similar to Avengers. That is how quickly you can create your own AutoGPT. But before example, just to show you here, I have just asked the question, write a weather report for Helsinki today, and the result was here, weather report. If I double click this, I can show you here what it was. It provided me that the current weather conditions in Helsinki are mostly sunny skies during the morning, will give way to mostly cloudy skies in the afternoon, high near 50 Fahrenheit, winds, and humidity is 53. You can see, why I'm showing you 2 examples is that you can have your AutoGPT configured for your task. You can provide any task for it and it will provide the thing for you. I just showed you simple examples. You get the idea how quickly with LangChain it is that simple to create the AutoGPT by yourself. Yeah, that's all for this video. I just want to show you that with the help of LangChain, we can create different use cases with few lines of Python code. I hope you learned something. If yes, please give thumbs up for the video. If you haven't subscribed, please do so. It helps me grow my channel and reach a larger audience. Thank you for watching and see you in the next video.